Okay, so let me quickly figure out how this app works. Okay, so your question is about vector addition. So if we go and look at something like this with one vector to the right, I'm just going to choose random units and say it's 20 newtons to the right, and let's say another vector with 30 newtons up. Okay, if we want to get the size, if we add these two vectors, I'm going to show this in two ways. Okay, the first way is doing the little triangle. When doing the triangle, we always need the correct direction of our resultant. So to do that, we are going to place, doesn't matter which one we place first, but we're going to place one arrow, and then the other arrow we start with the tail of the arrow, in other words, the tail of the arrow here, where the tip of the other arrow is. So like this. So we always place it like this, because this and this one is then 20 and 30. This would give the correct direction, because we can always think of the direction of this. It's to the right and up, so my resultant must be to the right and up. So my resultant must be that one, to the right and up. My resultant can't be left or down, because my two vectors that make it up are to the right and up. Okay, so if I then do Pythagoras, you would get that the resultant is equal to the square root of 20 squared plus 30 squared, right? So you'd be able to calculate it. Same thing with the angle. If I have a little 20 Newton and 30 Newton, and I have a resultant over there, and I want to get this angle theta, for instance, right? The way I would get that angle theta is I can go and look and say, okay, we know that we can use sine, cos, or tan. Tan would be the easiest here. If I don't want to just calculate the resultant, I could use any one of them, but if I use tan, it's going to be the opposite over. I'm going to write out the word, not just O. Opposite in the text, right? Over adjacent. I just can't write properly because this is on my phone with an app I don't know how to use in my finger. So then you can say it's 30, or you don't even need to write this part. For physics test, you can just say 30 over 20 and then shift tan, and you can solve for theta equal to whatever degrees, right? Okay, now let me just see if I can clear this thing. I'm just going to go back. Okay, so the second way I can do this is if I look at a Cartesian plane. That's a thing they call the parallel thing or whatever. But if I go and look at a Cartesian plane, you can always just redraw it if it's on a Cartesian plane to just be the triangles you're familiar with and prefer. But let's say I go and look at this. Okay, so on a Cartesian plane, let's say they give me two vectors. They give me one that's a vector to the right of 20 and one that's a vector up of 30, right? If I want to add these two, I can either go and shuffle them again, right? And redraw it for myself over here and say, oh, but it needs to be head to tail, and my resultant would be that one. Okay, the direction of that resultant makes sense. Or I can go and say, okay, well, this one is just 30 units up, this one is just 20 units that way. So the resultant would be where that rectangle is completed. Okay, so I can go and say, oh, that would be where this is completed. That's the same resultant, as you can see. And then you can see from my little diagram there, this over there is exactly the same triangle. And this would be exactly the same theta over there. So that's using the Cartesian plane. even if I have vectors that are pointing in odd directions. Okay, so weird directions is what I mean. I'll show you a way of doing that in a second, but let's say, for instance, I have my Cartesian plane, and I have a vector pointing this way, and a vector pointing this way. If I want to add them up, okay, these two might just cancel out nicely, but let's draw a better one then. Okay, so vector cancels adding this way, and let's say a vector, yeah, let's do it where it's pointing straight up. Okay, so now I can see this still has some units this way. This one has a few units in this direction, as well as a few units in this direction. So now it's not as easy as saying, oh, we need a little triangle or a little rectangle and we just point in a direction. It might be. Let's see if it works out nicely that way, where it might be just where those two meet, but it won't be as easy as that one. So that's where the triangle method is going to be useful again. So I'll redraw something like that again, with it pointing in odd directions, and show what I would do in both cases for solving it. So if I just want to show it visually, and I have my vector up and my vector in this direction, if I want to show it visually, I would prefer to use the little triangle method and say, okay, the second vector needs to start with its tail where the tip of the first vector is. And I can do it either way. I can say this is my first vector, this is my second vector, and then my resultant would be from this tail to that head. That would be my resultant. Or we could get the same result if we said, this is my first vector. Let me just draw its head nicely. This is my second vector. It's going to start with its tail at the head of the first, and then it will go from the tail to the head. Both the resultants look exactly the same. As long as we always draw it from the tip of this vector, the tail of the other vector, right? Head to tail type of method. Then we can see our resultant should be to the right in this case. If we wanted to do this on the Cartesian plane mathematically, what I would do is we would break it into this one specifically, right? Into its horizontal and vertical components. So if this was, let's say, 20 newtons up, this would be 20 newtons down. And this would be some newtons right, let's say 20 newtons right as well, just so you have like easy numbers to work with. And we could say, okay, let's break it up and then say we have our vector 1 is easy, it's just 20 newtons, right? And our vector 2 has two components. It has an x component that is, oh sorry, not 20 newtons, right? Vector 1 is 20 newtons up. Vector 1 is 20 newtons up, sorry. And our vector 2 has two components, has an x component of 20 newtons right, and it has a y component of 20 newtons down. So if I add 20 newtons up and 20 newtons down, they cancel out. Or in other words, if I add this, sorry, it would be 20 minus 20, 0. So there's no up or down component. And then all that's left is the 20 newtons, right? And that's what I saw from those diagrams. So I would go and break it into its x and y components and add all of the x components, add all of the y components. And this is the type of thing that would also work if we have vectors pointing in directions where they give us, let's say, something like this, and they say, oh, this is, let's choose it 50 degrees, and we have a different one pointing down like this at 20 degrees. We can always just break this up into its components and have some negative x component there, some negative y component there, some positive x component here, some positive y, someone distracted me, some positive y component here, some positive x component here, and we can add all of the x and y components, right? And then once we add all of them, if we calculate them, we could get the final resultant vector. Doing it visually as well, we'll just say if we want to add them, we do vector number 1 first, doesn't matter which one I choose, and vector number 2 needs to start with its tail where vector number 1's head was, and just draw how it looks, vector number 2, and then my resultant should point in that direction. Up, because the up component over here is clearly greater than the down component over there, and to the left because the left component here is clearly greater than the right component here. So up and to the left makes sense for my little resultant. Okay, so that's going more into depth. For the question you asked, the most important thing to remember is that either you can break it into its components on the Cartesian plane, or if you have nice things that point in this direction, it would be the vector like this. Or the most important bit that always works, even if the vectors are in odd directions, you could go and say it's always going to be from the tip of this vector, I draw the tail of my second vector, and the resultant will always go from the tip of my first vector to the tail or the head, from the tail of my first vector to the head of the second vector. So it's always drawn like this. Okay, so arrowhead, the tail starts with the arrowhead, the resultant is from the tail to the arrowhead. Even if we have 3 vectors or 4 vectors, I could add 1, 2, 3, 4. My resultant would still just be from this to this, and you can see that I added all of them with their tails next to the arrowheads of the previous one. So it works out that way. Hopefully this helps.